Okay, you're welcome to the Rhemabotics math class, and today we have bearing for us. So we're going to look at three aspects in this bearing, because bearing is broad, is vast. So please come closer. First of all, we are going to look at, please come closer. We're going to look at part one of this particular series. That's the first part of it. We're going to look at the introduction. Then the second part, part two, we look at the principles, that we need in this particular topic. Then we're going to look at examples also, because you need to learn how to solve bearing problems using the principles binding this topic. So let's go back to the introduction. Okay, so what's bearing? Bearing is the angle between a line and a reference direction, often measured clockwise from north if it is three figure. Okay, I'll explain what that means. So generally, bearing talks about directions, of points of a point from another point. But this is just a basic definition of what a bearing is all about. It has to be an angle between a line and a reference direction, often measured clockwise. So this is clockwise. So take note of that, clockwise. So this is your north, this is your east, this is your west, and this is your south. So when we say clockwise, this is the meaning of clockwise. Okay? So maybe an object or a place is located here, point P. Okay? So this angle here is the bearing from the north pole, from the north. Yes. So take note of that the angle must be clockwise. That's if it is three figure. But if it's not three figure, and let's say we are looking at the cardinal form, because I'm going to explain the two forms of writing bearing. Yes, there are two ways of writing it, the two different forms. So one of them is the three figure, while the other is the cardinal form. For the cardinal form, it can be both clockwise and anti-clockwise. So we're going to go straight up into how to write bearing in their different forms. So we are done with the definition. So we are still under introduction, don't forget, because knowing how to write a bearing is very, very important. So let's go straight up to that. Okay, so bearing illustration. Forms. Okay, so number one, we have what we call the 3-digit form. And number two, we have what we call, so I'm going to put diagram there. Number two, we have what we call the cardinal form. It's also called the army form. Yes, the army form. Okay, this is what the military, this particular way of writing bearing is what the military uses. Okay, so we have for the 3-digit form, it's like this. For example, the bearing. Okay, example, a bearing of A from B is 0, 50 degrees. Okay, 0, 50 degrees. What does it mean? It means from the North Pole, over is east, is south, is west. So you just take an acute angle of 50. So from B, this is from B, and this is A. So that's the bearing of A from B, and that's 50 degrees. So this is what we call the 3-digit form of writing your bearing. So these have been illustrated using this particular method. Okay? Now for the second method, the cardinal form. The same example, which is the bearing of A from B is 0.50. So this same word problem, using the 3-digit, you can see the 3-digit form is already here, fine. I've illustrated it. So I'm going to use the cardinal form to illustrate this. So what does it look like? So for the cardinal form, the illustration is still like this. That's for the diagram, but the writing is different. So 50 degrees, 50 degrees, 50 degrees. This is A and this is B. Okay? So how do I write it now? How do we write it? You say north, 50 degrees east. Okay? So you start from the north, that's the vertical axis, then you write the acute angle, then you write the direction the angle is going, which is what? East. Okay? Now, someone will be wondering, okay, can we just try another example in terms of writing bearing? Yes, so let's do that quickly. So now we are going to convert from, what I'm going to do right now is to teach you how to convert from the 3-digit form to the cardinal form. And I'll also teach you the reverse, which is conversion from the cardinal form back to the 3-digit form. Let's do that. Don't forget, we are still under introduction. We've not started yet. We are still introducing it. So after this introduction to principles, I'll tell you the formulas you need to solve the bearing problem. Then after that, in part 3 of this particular series, we're going to teach you guys how to solve problems. Okay, let's still go. We are still trying to teach you how to write bearing, because writing your bearing, the direction given to you in the 2 different forms, is very, very important. So let's go. So I can call it bearing forms conversion. Okay? Bearing forms conversion. Okay? So let's say example 1. Convert. Let's say 300. Sorry, 0. Let me say 0.56 degrees. To its cardinal equivalent. Okay? So solution. You draw your north, draw your east, and you draw your south, then west. Good. So you walk with the acute angle given to you. Don't forget, I always move from the north clockwise. Okay? Whenever we are doing the 3-digit. Okay? Since it's conversion from the 3-digit to the cardinal equivalent, I'm drawing what it is now first. After the diagram, okay, I'm going to show you how to put it in the cardinal form. So don't forget it's north, yes, east. Okay? So let's go. These are to write it north. You start from the north pole, the vertical axis. Then you now write the angle 56 degrees. Don't forget 56 degrees is less than 90 degrees. Don't forget it's less than 90 degrees. So that's why when you're writing it, the acute angle for the cardinal form is very important. You have to take note of the acute angle you're working with. So, in this particular question, we've already given us the acute angle. I'm going to do another example where it will be an obtuse angle. So, I will teach you how to convert the obtuse to acute. Okay? Let's go. So, this is the easiest way, this is the easiest question that is being convert. So north 56 degrees east. Okay, I'm done. I'm done with number 1. So let's move to number 2 example. So this is the 3-digit form, this is the illustration, and this is the cardinal form. Hope you're getting the point. Let's go to number 2 now. So we are going to convert. We are still converting from the 3-digit to the cardinal. So for example, 150 degrees. Don't forget it's 3-digit. So when you have a 3-digit angle, don't put 0 anymore because it will not be 4 digits. So if it's a 2-digit number, you write, for example, let's say it's 15. What we just did now, 0.15. But when it's 165, for example, you just write it like this, 165. What if it's just 1 digit, 5 degrees? What you do is put 2 zeros, because the point is, it has to be 3 digits. 1, 2, 3, 1, 2, 3, 1, 2, 3. I hope you got it at point. Let's move on. Okay, so we have to convert 150 degrees to its cardinal form. Its cardinal form. Let's see what that looks like. So the cardinal form, it will be, first of all, the illustration. Don't forget, I don't play with diagrams when it comes to bearing, because the diagram will make you understand it. So north, east, south, west. So let's go. We are going. It's an active angle, don't forget. We are going. Within this box, all the angles here are active because they are less than 90. So the moment you cross 90 degrees, you start going towards 150. You're going. Don't forget, here is 180. So 150 should be somewhere here. So the whole of this angle is 150 degrees. So for the 3-digit bearing, you can leave it like this, fine. But when you're converting it to the cardinal form, you have to find this acute angle. Very, very important. Now at this point, this angle is no longer clockwise. This angle is anti-clockwise. Take note of that, because the clockwise principle applies only for the 3-digit bearing. But when it's the cardinal form, I told you, it can be clockwise, it can be anti-clockwise. Okay, so let's do this anti-clockwise. So what is the active angle here? It has to be 180. Don't forget, the full angle from here to here is 180. Don't forget. So 180 minus 150 is what? 30 degrees. So we are going to work with that. And I told you, we normally work with the vertical axis first. So don't forget, the angle is 30 degrees is starting from the south. So south, 30 degrees east. I hope that is understood. This is a bundle of knowledge. So don't play with this. Maybe you have to rewind and watch this particular that I just did now. Because if you can understand this, bearing will not be a problem when it comes to illustrating. So let's move forward to another example. Because you need to understand this particular conversion holistically. So let's move on to another example. So I have another example for you. Still from the 3-digit form to the cardinal form. Let's say we have 300, for example. 300 degrees. Okay? So we are going to illustrate it now quickly. What does it look like? What does 300 look like? Okay? This east, this west, this south. Okay, look at 300. I'll cross 180, cross 270. Don't forget, it has to be clockwise for the 3 digits. Yes. So 190, 180, this is 270. So 300 should be just 30 degrees above the 270 here. So that will give us the full angle is 270. Don't forget. And from here there is 30. But we are not going to use this acute angle. Instead, we are going to use this. Somebody will be asking us, why? Why must we take this acute angle? Why not this? Don't forget, the bearing must always come from the vertical axis, the vertical pole, either the north pole or the south pole. So you don't take your bearing from the horizontal, that's west, east, no. Don't start, always start from north, or you start from the south, because that is your reference. Take note of that point. Your north and your south is your reference point. So that's where you take the bearing from. So if from here to here is 300, degrees. What is this? This small angle here, let me call it x. It will be x now, angles at the point will be equal to what? 360 minus 300, which is what? 60 degrees. So that's what this small angle is. So our acute angle is very important. We are going to use it to get our cardinal form. So let's get our cardinal form. It has to be north, because the angle is starting from here, heading towards the west. So north, 60 degrees, that's x. Don't forget x is 60. So north 60 degrees, west. Okay? So I'm done with converting from the 3-digit bearing to the cardinal form. Now I want to teach you how to convert from the cardinal form back to the 3-digit form. So we are still on introduction. I'll just do 2 examples on this and we'll be done with this particular part. So sorry, I know you intend for this video to be very long. That's not my intention, but bearing is vast. And if you can take your time to go through all this, you will have the basic knowledge of bearing, the fundamentals of bearing, which will help you to solve problems. And at this point, I would like to say that please, if you've enjoyed this video so far, go and subscribe to the channel, click on the subscribe button, click on the like, make sure you drop a comment and also share. Okay, let's move on. Now, how do we convert from the cardinal form? Let's say north 20 degrees west, okay, to, let's convert it now to its 3-digit form, okay, so, or 3-digit equivalent, let me put it that way, convert it to its 3-digit what? Equivalent. So if I want to put this, which is the cardinal form, in the 3-digit form, what do I do? Let's say I have this in a question. How do I illustrate it? How do I put it in the 3-digit form? Don't forget, this is my north, this is my east, south, and west. They said north 20 degrees. That means the angle is coming from the north, but it's heading towards the west. They said north 20 degrees west. So it's coming from the north. Watch. 20 is not a big angle, it's small, but it's still acute. So here is 20, very small. Then I cannot take my line here. So that's where, don't forget, that's where the point is. This is where that point, object or place is located. So the bearing is 20 degrees, not 20 degrees west, heading to the west. Don't take it to the east, except there is east written here. So how do I now put it in the 3-digit form? So watch, this part is very important. Don't forget the 3-digit form is always clockwise. So let's go. That's how to get the 3-digit equivalent. So I'll call it x. So what is x? X is equal to, if the full circle is 360, what you do is you subtract this 20 from it and you get, which is 340, and you get your 3-digit form. So this is the 3-digit form of this cardinal form. So I can make a bold statement and say, therefore, north 20 degrees west is equal to 340 degrees. Yes, they are equal and equivalent. Thank you so much. But before I end this video, I'm going to do one more example, because some people are wondering, how is somebody just did this part? Let's do something that has to do with the south and the east. Okay, something like that. So let's do that quickly. So let's say we have south 40 degrees. Let's say east. Let's see what that means in the 3-digit form. Okay? And this is the end of today's episode. This is the first part. Make sure you look forward to part 2 of bearing. Okay, let's go. So we are converting this to the 3-digit form. First of all, north. You draw 4 cardinal points. South. And this is west. Okay, let's go. So 40 degrees from the south. Look at it, south, 40 degrees east. That means coming from the south, heading to the east. Coming from the south, heading to east, not west. So here is 40 degrees. Then you draw your line to show your point. Now, don't forget that the 3-digit bearing, or the 3-digit form of writing, is always clockwise. Clockwise from the North Pole. So you have to get the equivalent the North Pole. So how do you get that? I can call it x, and that x is equal to 100. Since the full angle from here to here is 180, don't forget, that's half of the circle. So the full angle is 180. So 180 degrees minus 40 degrees is equal to 140 degrees. So I can also make a bold statement here. I say that south 40 degrees east is equal to 140 degrees. So thank you so much for being part of today's episode of bearing. Look forward to the second part of this video because I'm going to show you the principles you need to solve problems. I don't joke with principles. All my videos on this channel, principles are premium. They are very important because principles make mathematics. Principles make mathematics easy. So whenever you're finding it difficult to solve a problem, know that you don't know principles, you don't understand them, you don't even have it at your fingertips. And that's why you're struggling. The moment you start understanding principles and knowing them, you'll be able to solve problems. At that point, mathematics will be very easy for you to solve. So it's my desire that you find mathematics very, very easy because truly, mathematics is easy. So look forward to that very important part of this bearing series, which is part 2, which has to do with what? Principles. So after principles, don't forget part 3 is where we conclude by solving problems. That is where we are heading to. Until you pass through this and this, you can't do this. Thank you so much for being part of this. Make sure you subscribe. Do that to support the channel. Thank you so much. See you.